Hello, today we are going to look at section 3.2 and we're going to answer the question of how do you solve systems algebraically. The last section we solved systems using graphing, and for most of you, you don't really like graphing, and it's not the best way to solve systems of equations, especially ones that don't have nice whole number solutions, because it's more difficult to find the exact solution. Solving systems algebraically will allow us to find the exact answer to systems. Okay, there's two ways to do it. Substitution is the first way. So we use substitution when one or both of the equations are set equal to a variable or can easily be changed into y equals or x equals form. For example, let's say I have a system like this. I have a system of equations. One of the equations is set equal to x. So we could use substitution in this case. We can simply take what x is equal to and substitute it in the other equation. And what will happen there is if I substitute this in, I'll get 2 and then negative 3y plus 3 plus 5y equals negative 5. It's going to look like that. So I've substituted this in for x because that's what x is equal to. Now I have an equation with one variable and I can solve that. And I get 11 for y. Now remember, a solution to a system of equations is an xy coordinate. I have the y coordinate, but I still need the x coordinate. So I need to substitute again, substitute that in for y to get the x coordinate. So once I do that, I get negative 30. So if I was to graph this, to find that point of intersection would be difficult because I'd have to scale my graph and everything else because of the big numbers. So solving systems algebraically is much more convenient. Okay, let's try one more with substitution. Okay. So both equations are in standard form, but it would be easy to take the second equation and solve for y there. I just have to take this term, bring it over to the other side, which would look like this. Positive 2x plus 4. Okay, so from there I can take this, substitute it in for y in the first equation, solve for x. So I grab 3x plus, combine like terms, subtract 8, looks like x equals negative 1. Okay, substitute that back in here to solve for y. Looks like I get 2. So negative 1, 2 is the solution to that system of equations. So that's substitution. The other process is called elimination. Okay, we use elimination typically when both equations are in standard form, or we can put them in standard form. Okay, so here's a system of equations. They're in standard form. It would not be very easy to solve either of these equations for x or y. We might be able to do it for the top one, but let's use elimination here. Now with elimination, what we need are opposites. Okay, so we need opposites for x's or opposites for y, because what we're going to do is we're going to add the equations together and eliminate a variable. Now we don't have opposites right now. An opposite would be like positive 5 and negative 5, or positive 5x, negative 5x, or negative 9y and positive 9y. We don't have that right now, so we have to multiply one of the equations by something that will create an opposite. So looking at this first equation, if I multiplied everything by 3, I'm going to have a 9y there. So then I'll have opposites. So this is how I'm going to show it. I'm going to bracket that. I'm going to multiply the whole thing by 3. So I'm going to get 9x plus 9y is negative 45. Okay, I got to multiply everything by 3. That keeps the equation balanced. Leave the bottom equation like it is. Now we add them together. So we get 14x. The y's go away because that adds up to 0, equals negative 42. Okay, we've eliminated the y variable. Now we just solve for x. Divide both sides by 14. 42 divided by 14 is negative 3. So x equals negative 3. Again, we still need y, so we have to substitute back in. Now we can substitute this negative 3 in for either equation. Okay, so let's use the bottom one. So we have 5 times negative 3 minus 9y equals 3. Negative 15. Add 15. Looks like I get negative 2. So negative 3, negative 2 is the solution to that system of equations. Okay. Let's try another one. So now I've got another equation here. We don't have opposites, so we have to make opposites. So then there's no number I can multiply this first equation by to create an opposite right away. So I need to multiply both equations by different numbers to create opposites. So if I just look at the x's, I can multiply this top equation by 4, which would result in 12x minus 24y equals 36. What would I have to multiply the bottom one by? I have to multiply by 3, right? Because 3 times negative 4 is negative 12x plus 21y equals negative 48. Okay? Have opposites on the x's, so the x's are going to be eliminated when I add this together. So I get negative 3y equals negative 12. Divide both sides by negative 3, I get y equals 4. Substitute back, plug 4 in for the y here. Again, I could substitute it in either equation, I'll get the same answer. Subtract 28. So we get negative 44 there. Divide by negative 4, I get 11. So 11/4 is my solution. So it doesn't matter which variable you solve for first. In this first example, I solved for x first, substituted back, and I got y. The second equation, I solved for y first, substituted back in, and got x. Okay. Now you could end up with some special cases here. Let's try one more. start with that. So looking at that, if I want to have an opposite, I might say, okay, I need to multiply this top equation by -3, because that's going to give me a -6x there. Okay, but what happens here? Not only are the x's eliminated, the y's are eliminated as well. There's nothing left over on the left side, and this adds up to -4. This 0 equals -4 makes no sense at all. Therefore, we have no solution. If I was to graph these, I would have parallel lines. Okay, and then finally, if I have something like this and I multiply this top equation by 6, if I multiply the top equation by 6, I get 6x minus 6y equals 24, plus 6y equals -24. If I add those together, not only are the variables gone, but it equals 0. 0 equals 0 would indicate that these are the same lines, so we have infinitely many solutions. So those are two special cases that we might run into. Okay, so you can solve using substitution or elimination in this section and get your solution to your systems that way. Thank you.